How's everybody doing? Good? Who's still asleep? No. So, I'll start with a quick disclaimer. I gave this presentation at B-Sides Nashville and at Wall Street DerbyCon. After DerbyCon, somebody told me using blazing saddles for my presentation. Mongo, get it? That's offensive to people because there's N-words in that movie and things like that. Okay, so I've changed it to something that hopefully will be offensive to nobody, or at least slightly less offensive and maybe amusing, maybe not. You may think I'm crazy. So this presentation has now been retitled, Making Katy Perry Cry, NoSQL for Penetration Testers. All right, so I have replaced all the references to Blazing Saddles with Katy Perry references. So nobody walked out. Wow. All right, so why do we give this talk? I mean, this is territory we've covered before, right? Brian Sullivan started really looking at some of the NoSQL issues in the Adobe blogs in 2011. Will Urbanski gave an excellent talk at AppSec USA in 2012. And Ming Chow, which we're listening to his talk, is where I got started in NoSQL research in DEFCON 21. Really, really good talks. I encourage you, if you're interested in this stuff, to go and check them out. They're all available on the internet, all this material. But the problem's getting worse. There's new NoSQL platforms coming out every week, and every one of them has the exact same issues that their predecessors did. And in new revisions of Mongo, new revisions of Couch, they're not fixing anything. In fact, things are getting much, much worse than they were. Microsoft released a Azure platform as a service NoSQL platform called DocumentDB. There's no way to write a query for DocumentDB without SQL injection. Basically, you have to insert inline HTML into your query strings in DocumentDB, and there's no other way to do it. So some of the POCs that were in the old code didn't work especially well. So if you tried some things, they were written for like real JavaScript and not for the JavaScript interpreters in NoSQL databases. So giving penetration testers a toolkit and kind of what works, what doesn't work, that's one of the goals of this talk. More and more companies are moving to this stuff, and it's it's just becoming more common. And my display view is really, really cool. And pen testers really need to start focusing. So let's talk about Mongo, but not in reference to these. I was wondering if that would drive the whole presentation off the rails by the fourth slide. Nobody walked out yet. Again, that's great. And Willie's laughing, so that's good. Some of you look like you'd be really content if I just left this slide up here for the next 40 minutes. This is Mongo. So this is MongoDB by Tianjin. Tianjin is a billion with a B dollar company who's written a NoSQL technology that has some of the worst security of all of the NoSQL platforms. How many people were at Matt's talk yesterday in the stable talks? Okay, yeah, a few of you. Good. So those of you who were there, some things Matt talked about, a really excellent talk about logging and what Mongo logs by default and doesn't log by default. If we'd be thinking about, as we're talking about these things, the things that Matt talked about and how hard these attacks are going to cover are going to be to detect. So why do I pick on MongoDB? Like I said, it's a billion-dollar company. This is a real stat they use. 49% of LinkedIn member profiles mentioning NoSQL technologies reference MongoDB. I have no idea if that's a valid stat or not for measuring market penetration. That's what they use, though. So it could say we ripped MongoDB out because it sucked. I don't know. But, somehow they probably pulled that out. There's frequent releases with a lot of changes. And so one of the things that they specifically call out is Mongo is on 6-month release cycles. So they'll go like 2.2, 6 months 2.4, 6 months 2.6. So, but they say specifically in each set of release notes that we're going to break your stuff probably if you upgrade. So, what's the motivation to upgrade? And I like this quote. Tianjin is just very oblivious to security issues. Rich Mogul was on Security Weekly. You guys know Paul Asadorian, I'm sure. Talking about the platform and talking about conversation with MongoDB guys. And said we were on with the MongoDB guys talking about the security of the platform, and it was really clear that they just didn't care because their customers weren't asking for it. And if you think about it, NoSQL is really driven toward a developer customer base, and the developers, they don't really care about security, right? So, moving on. So if you're not familiar with NoSQL, here's a little bit of structure. And one of the things I want to preface this with is this is the MongoDB structure. And one of the problems I think we really have with NoSQL is there's not standards as you move between platforms. So in a traditional relational database, you have databases, tables, columns, and types, rows of records, right? And this is all very static. So once it's set, everything has to have certain matching characteristics and some commonality. In a NoSQL database, everything's very logical. In Mongo, you start with the top level of databases, and then you go into collections, which is a subgroup, and then a subgroup that are called documents. Then inside each document, there's a key value pair. But inside the same collection, the documents don't have to relate to each other. You can have a document with 3 key value pairs. You can have another document with 5 key value pairs. You can have the same key value pair with sort of an integer in one document, with a string in another document. So, dynamic stuff very rarely works in security when it just does whatever you tell it to do. So, you guys can probably start seeing where some of these problems are coming from. Data, and this is sort of what we talked about before, but you see we have first name, last name, and an integer data type for widgets in a traditional RDBMS. In NoSQL, you see everything is stored in this JSON-y looking thing, which is actually, they use a format called BSON, which is binary JSON. And what this gives you is a few little encoding, decoding, performance enhancements. It allows Mongo to store more data types than traditional JSON. So there's some advantages to using BSON. Other databases, does anybody know of a NoSQL database other than Mongo that uses BSON? No? Yeah, I think they're the only ones. Everything else uses traditional JSON. So this is sort of a market differentiator. But you see, I mean, it's very, very simple. I mean, it's just you have a key and you have a value, you have a key and you have a value. And you see, within the same collection, we could actually change between strings, integers, add extra attributes like the one at the end. So yeah. And then for queries, it's really just syntactical changes. So you see, and I'm really bad with SQL queries, so that may not be right. I don't know. But you see, we select something from something where the username matches something. In Mongo, you pass in, here's what I want to go get. I'm going to set a 1 for the key value pair I want to get. So same concept, just in a different format. If you guys have questions as we go along, feel free to jump in. We'll save time for questions. So it's good, right? Happy Katie. Built for performance. They scale very well. You can replicate. You can solve complex problems in a distributed fashion. They're very dynamic, flexible. Since we can change the way we're storing data, since we can store extra data, it's very easy to develop for them, right? You guys probably know who's written code for a relational database in the past. Okay? If you want to change the way you're writing things to the database, it's pretty hard, right? You have to restructure the database. With this, you just change the code and start storing it because it's so dynamic. So, but then, security conferences start talking about security things, right? So, like we talked about before, we now have SAD, Katie. We have no standards between the SQL platforms. You have to choose the right database for the right job. So, where MongoDB might be appropriate, CouchDB might be appropriate in another setting, Cassandra might be appropriate in another setting. And if you decide to move platforms, you pretty much have to relearn everything from scratch because there are no standards. There's not that consistency, whereas with traditional relational databases, you're going to find sort of the same feature set, the same architectural structures between platforms. Things may work in a little bit different way, but anyway, and the security's pretty bad across all of them. We're talking a lot about Mongo today, just because it's easy to focus on one for sake of example, but all of them pretty much have the same problems if you look across the different platforms. So, and then we have Angry Katie, and there's no authentication required by default on most of these platforms. There's weak or plain text password storage. Mongo uses a single round of MD5 with a static salt. Couch used to use SHA-1 before 1.3, and they moved to something called, I wish Josh was here so he could tell you, it's PBDKF2, and they did 10 iterations of it. But in the tool that I'm going to show you guys in a minute, I can crack one of those faster than I can crack a SHA-1 hash. So it really wasn't a performance improvement. Pretty much everything's going to be clear text with no SSL across the wire. There is in Mongo, starting with 2.6, they offer it, but it's only in the enterprise version by default. If you want it in the open source version, which most of your cloud storage or your cloud provider is going to use, then you have to compile everything from scratch, including every time you patch it, you have to recompile everything locally with SSL support. Data encryption, no, there's nothing inherent to the database. And the manuals for a lot of these, Cassandra, Couch, Mongo, all say use this only in a trusted environment. Yeah, right. Okay. And we'll talk about how many of these are sitting out on the internet wide open. Some people apparently think the internet is a trusted environment. And there's a lot of reliance on the drivers. So the stance a lot of these NoSQL platforms seem to have taken is we're going to index your data, we're going to find it for you, we're going to solve it, we're going to distribute it across multiple nodes, we'll do a replication. But if you want to do security, we're going to push that all into your application or your code. We're going to push it all back into the drivers and what's connecting to the database. And they're almost all like that. So NoSQL equals no authentication, at least by default. So I did a little test. I did one back in February. I did a more recent one before coming here. And how many of you are familiar with Project Unicorn? Okay, a couple people. Project Unicorn was a project where they scraped the whole internet for anonymous NoSQL databases, anonymous MySQL access, or no authenticated MySQL access, and Heartbleed. And they had a massive database and stuff. They didn't provide a way to actually extract the data. You could just query it. And they had something like 102,000 MongoDB instances exposed to the internet with no authentication by default. And Shodan had about another 50,000, I think. So I tried to scrape as much data as I could from this, and the people at Project Unicorn apparently get mad if you write a curl script that just goes page by page and scrapes the IPs out. Because when I got to about page 30, all of a sudden it quit working, and then it never worked again. So I think they figured out what I was doing. But and then I extracted the data from Shodan, and I actually paid them for that like you're supposed to, like a good security citizen. Excuse me, my throat's dry this morning. So I was able to get about 36,400 of these databases out. There were approximately 150,000. So I figured, how many of these have no authentication turned on? And I also checked how many of these are behind on their version. So out of those 36,405 servers, we had 10,626 exposed to the internet with no authentication. That's actually down from what I did in February, which there were nearly 19,000. But of those 36,405 servers, most of them were just offline because these things are fairly disposable. Fewer than 1,000 actually had authentication enabled on the database. So, read the manual. The most effective way to reduce risk for your MongoDB deployments is to run your entire MongoDB deployment, including all MongoDB components, MongoD, MongoS, and application instances, in a trusted environment. So, I guess at least that many people think the internet is a trusted environment. So it gets worse. Let's see if you guys, yeah, you can see it's pretty good. So, one of the other problems with this is these things don't get patched. They're disposable. Most of the cloud providers, so Google Cloud, AWS, Azure, and there's one more that I'm forgetting, offer MongoDB as a service. So it's one click, stand it up, and go, right? Well, so one of my clicks stands it up, and they just leave it sitting there. So what's interesting about this, in April, 2.6 was released. And if you look, the colors on this graph are pretty bad. Only 9% of the instances that I tested were on version 2.6. 67% were still on 2.4. Now, the really scary part is this. If you look at about the right-hand corner of that graph there, those are all 2.2 and below. There's a remote code execution vulnerability for 2.2 and below. So there's 3,000-ish machines on the internet sitting with remote code execution vulnerability. And that's just what I tested. Remember, I only tested about 10% of the total of what was indexed. So as this happens, like we were talking about before, did you know you can deploy Cassandra, which is another bad NoSQL database, and RabbitMQ? Well, you can now deploy MongoDB with one click. And what happens, you get a developer, they click, okay, I mess with it a little bit, and then I just leave it sitting there. And that's it. It just sits, right? Companies make huge deposits, these cloud providers, if the machine's only costing $20, $30 a month. They don't notice, and it sits there. So what happens the next time there's a 0-day for MongoDB drop, like the remote code execution vulnerability from 2.2? It just sits. Nobody patches it. Nobody remembers it's there, right? But, I gave this talk at DerbyCon, like I said, at the Wall of Sheep, and somebody's feedback to me after that was like, well, there's all these things exposed to the internet, but the sum total of it's probably not worth, or the sum total of the data is probably not worth the loss change in the city. Well, I'm going to start looking at some of these. which I have no problem saying because that's not like I connected to them and typed in a username or password or tried to figure out. That, it's like HTTP, right? Sitting on the internet with no authentication. What goes on? So some of the interesting things I found, there was session tokens for a student information website that also contained the student's social security numbers. There was a production pricing database for an e-commerce site. Health records with ICD PIN codes and names and addresses and phone numbers. So that was pretty good. And I found some developers. This is really interesting. And I have friends who can tell you if there's a valid credit card number or not. I worked in banking for a while. And so they had a little e-commerce application. And what they did is they put their real credit card information in, including their names, addresses, zip codes, CVV2 codes, to test their transaction for a penny on their real credit cards and then left the database sitting out on the internet. Smart. Yeah. So if you're pen testing, here's some things that you can look for, because this is a talk for pen testers. If you get shell on a server, the config for MongoDB is stored in mongodb.conf. Okay? If you comment out, there's a line that says auth equals true if you turn authentication on. If you comment this out, it turns off authentication on everything. So, and I don't mean everything going forward that you create, I mean everything that exists already, it shuts down, except for the web server for some reason. I haven't figured that out. But you do have to restart the Mongo servers. Yes, thank you. Yeah, but it's a pretty quick restart. I mean, it doesn't take long to load. And the other thing about it is if you do have something that's authenticated, like applications are passing usernames and passwords, that doesn't break. It just accepts whatever you pass into it as good. So that's kind of disturbing, I think, anyway. Run will act as a shell wherever you launch the Mongo client from Connect. So when I first started doing this, I didn't understand that, and I launched the Mongo client from my machine, and I was like running netcat, and I was getting shells back, and I was like, this is awesome. Then I looked at, I ran ifconfig, and I was like, wait a minute, this is my IP. So if you get a local shell on a server, you can use the Mongo client to go in and do things in the context of the Mongo account. The rs.status command, so Mongo's replication technology is replica sets, so you actually have members that vote on who's the highest and have priority. It's pretty standard replication type thing, but that will show you where the other members of the replica set are if there's multiple members, so maybe you go look for other things. The other thing that's interesting about the replica set is if you can get a shell on a server, you can add your own Mongo instance as what's called a priority 0 replica set, or replica member. So it will basically receive everything that's written to the database, but will never be made the master. So you can silently do that, and like Matt talked about yesterday, there's almost no logging, including for that, turned on. So you just steal all the records, stand them up on the internet, switch them out. If you enter a command with no parameters in the MongoDB shell, it will actually show you the JavaScript that it's executing. So if you want to do research, see how something works, look at that. So, like, if I do, oh yeah, I'm sorry. There it goes. Is that better? No problem. I didn't think about that. So, you put my head right now. But yeah, you see, I didn't feed it any parameters, so it will actually show me the code that it's executing on the back end. So it's great if you're researching. So, system.users has the usernames and weak password hashes, and I've found a lot of places where there's no authentication turned on, but for some reason there's still username and password hashes in the application. It's in the documentation. The salt value is just Mongo. So they do the username, :Mongo, : and then the password, and they run it through one round of MD5. No. I have a tool for that. And it will do it all for you. Let's see. System.indexes will actually tell you where the important stuff in the database is, because those are the fields they've chosen to index to speed up searching. And there is a web server runs on TCP 28017 by default before 2.6. It's disabled in 2.6. And there's a REST API. Now, the REST API is not turned on by default, but you can actually query the database directly if it is turned on. There we go. Okay, NoSQL equals no encryption. So like we just talked about, everything over the wire is plain text, unless you've got the newest version and you're paying $7,500 a year for enterprise, or you're compiling everything from scratch every time you patch it, which most places aren't going to do. One round of MD5, they do use a nonce over the wire, not brute force. And for data encryption, you're kind of on your own with 4.2.6. I'll talk a little more about that. So now we get into some of the really fun stuff. So one of the common misconceptions about NoSQL databases is there's NoSQL injection. And yes, can you go pick where 1 equals 1 dash dash? No, that doesn't work. But that's just because the syntax has changed. We can still do all the same things we did before. So, and it's the exact same concept. So if we look at the pre-2.2 example, and I'll explain why it's pre-2.2, or up to 2.2 rather. We close the variable off, we insert some bit of code we want it to run, DB, and just some garbage collection name. The driver really doesn't care. The driver will go attach to whatever collection it was told to get the stuff from, stop find, and then create a dummy variable so your syntax is right. Then it will return all the records in the database. In 2.4, Mongo chose to, or Tengen rather, chose to take out the access to the DB class, along with several other things. And that was actually really interesting, because what they said was, remember we talked about how backwards compatibility can break? Well, between 2.2 and 2.4, they removed access to a whole bunch of classes from the drivers. And their answer for backward compatibility was, rewrite all your code. It actually says that in the release notes. If you use this stuff, rewrite all your code. So, they didn't, even though they took out the DB class, they did left a hole where any value which evaluates to true, and you say return true, will return every record in the database. So it didn't really solve anything. So you can do this. So the first one's kind of an interesting mutation. Mongo, by default, thinks it has everything in its database. So if I query for something that doesn't exist, it will say, yeah, I have that, and its value is null. Yeah, so I say this dot some garbage thing is not equal to some garbage thing. It says that condition equals true because this dot some garbage thing is equal to null. So, or 1 equals 1, or just return true. And we can use that for some fun things. And one other thing to mention, between 2.2 and 2.4, they changed interpreters from SpiderMonkey to VA. So if you want to inject other kinds of JavaScript, you have to adapt. Okay, then there's the client-side issue. Remember we talked about security goes to drivers and the clients a little bit? So PHP and Express.js have an interesting behavior, and there may be other things as well, where anything in square brackets gets turned into an associative array. Associative array is what the driver expects as input. So if we have a parameter name and we put $ne in square brackets, which is not equals, and some garbage value, PHP turns in an associative array, feeds it back to the driver, says, give me this, and MongoDB sees, give me back everything that's not equal to that thing. So if we feed it garbage, and there's also another similar exploit using greater than, and I'll show you that a little bit. But I give credit where credit's due. I was at the doctor's office back in April, and I was sitting on Twitter, and I get this tweet. You never have to ask for a security exception to run MongoDB again. And I started looking, oh, we added this, there's new authentication methods, web interface is disabled, there's role-based access control, there's auditing, there's encryption in transit, and encryption at rest, it's great. All the security problems in MongoDB are solved. And I was like, well, crap, this poor B-side national, and I gotta redo this whole talk, So, but, Katie says stop. There's no authentication by default still. The default distribution does not contain the SSL support like we talked about. You have to pay. The Xong encryption is pricey. It's a commercial product you have to insert into MongoDB, so there's still no way, like with MySQL or Postgres, to use some of the open source encryption libraries. And the password hashing is still just as bad as in previous versions. So it's really not getting any better. So, take out this information. So there's no tools to deal with this. And I wrote a Python tool called NoSQL map. And you guys who have gotten up early are incredibly lucky because you guys are the first people to get to see NoSQL map 0.5, which will go up on GitHub as soon as this is done. How many people have heard of NoSQL map? Just out of I got to promote better. That's all. That's shameful. I'm an attention whore. So anyway, so I created this tool, and it does all the things we just talked about and more. And I ripped the name off from SQL Map, but I made it because I like SQL Map, but I made it menu-based, which is different. So because one of the things with SQL Map that really grates at me is the case-sensitive command line. I don't have a big long SQL Map command. I put like a lowercase d instead of an uppercase d, and then the whole thing doesn't work. I use menu. So you gonna see it? Yeah. All right. Okay. That's my host name for my big saddle. All right. Let's see if this is great. So you see we've got some different options. Now those of you who've seen the tool before, there's two big changes in 0.5. First, you see there's a change platform option. So the previous versions only supported MongoDB. This version now supports CouchDB as well. So you can actually flip. The plan going forward is there's going to be a maintenance release. Now I've got the core feature set. There will be a maintenance release where I fix all the things I broke in the major release. And then there will be a major release. And in every major release going forward, a new NoSQL platform will be supported. So about 3-month cycles on those, hopefully, depending on my free time if I have no help. I'm sorry? Cassandra's next. Yeah. Some of them are even worse. Have you ever read the manual for Cassandra? Yeah, we actually were by our spam filter vendor last week where I worked. So yeah. We were our spam filter vendor informed us they were moving Cassandra as well in there. So a lot of people are using this stuff, and that's what I was saying. A lot of people are moving to it because it's so easy to develop for, and plus its storage limitations are so small compared to traditional SQL databases. So, all right. So we'll work with MongoDB since we talked about MongoDB, right? We'll stick with that for today. So first thing, we can scan for anonymous access. You can select the subnet. Everybody see it? Okay, I don't even make it any bigger. Zoom it a little bit. Okay. How about that? Better? Worse? Okay. It's like the eye test. Is number 1 better? Or number 2? Yeah. Okay. So you can load a list of IPs. You can scan a subnet. I'm just going to scan my little VM subnet. I hope I remember to turn the network cards on everything before I started this. I did this thing threaded. I really. So you see we found some MongoDB instances, we recorded the version, and we had the option to save the results out to a CSV file, that, and then we can actually send targets from here directly in the SQL map. Use number 1. Doesn't matter. I'm going to go set one other option. So you see some of the different things you can set in here. I'm going to go ahead and set my local IP. So I've forgotten what it was. Things many times like that, so you know. Let me explain to you why we're setting a local IP. There's 2 reasons. The main reason is all of these databases, whether it's Couch, Mongo, are designed to make the data very portable. So there's code written to basically replicate entire databases off to another instance. So if I'm an attacker, do I really want to sit on your server and assuming they might have the crappy logging turned on, run queries, and do things that might get me caught? No, I'll just take and replicate the entire thing, which there's no default audit instance or auditing for, out to my own server, and then I'll play with it outside your purview. So the second reason is that there is a Metasploit module for that remote code execution exploit we talked about, and this will automatically open the shelf back to that IP. All right, so first we're going to start network level attacks. So these are those anonymous things we talked about. So the test, we don't need any creds. It'll test for the web interface. Yeah, let's test for the REST API just to show it works. It works. We enumerated the databases from the REST API, and then we have different things. Some are information gathering, some are attacks. So server version of platform, just for fun. Yeah, this one's 226, 64-bit, no debugs enabled. We can enumerate databases, collections, and users in the database we just attached to. So you see, I'll go through them a little bit. Enumerate the databases, enumerate the collections. So we get an idea of what might be interesting to take. And then we start dumping out the database using password hashes. I'm going to skip cracking the hash for now because I'm going to show you something more interesting with that here in a minute. That. Okay, let's clone a database. Which one do we want? Use the data. Now, I have a default instance of Mongo running on my attacker machine here. So just apt-get mongo-10gen once you add the repositories and so forth. App user data, that one looks good. Let's take that one. Database does not require credentials. We knew that already. We attached anonymously. And it's fuzzy because I don't have indexing turned on the default instance, but it still replaces the database. We hit enter, and that's it. So let's drop back over here. I'll go into my default instance, which we were just into the demo a minute ago, show DBs. We now have database app user data stolen. This is case sensitive. Drive show collections. db.users.users.line. And I've replicated the entire database to my hacker machine. You know how many lines of code that took? One. Because they're designed to port the data around, right? So, I mean, other than the interface stuff. Oh, and I should have mentioned in 0.5, for those of you who've seen this tool before, every database platform has been moved into a freestanding Python module. So really, I'm just using my front end, but you guys, and some of you who follow me on Twitter know what happened last week with somebody copying the code from NoSQL map and doing their own presentation. I won't get into that right now. As long as you provide attribution, you can bundle it with your own tools, import it to your own stuff. So yeah, and so that's pretty much it for your network level attack. So you can actually run the remote code execution exploit directly from here. All right, let's turn to the main menu. But let's say we don't have something exactly like that. Let's say we have something more like IP start. Maybe we have something like that right there. Simple application query for your user data. So let's set our options up. Our target host is going to change to the web server. Close that. Okay. Port, app path, we need to feed in app path with the parameters. Unless you're doing post, which I like to do get for demos because it's more visual as to what's happening. This is really hard to see. I know it's good for you guys there, but it's really hard to see down here. This is big. Alright, so there we go. Alright, so back to the main menu. Right. Web app attacks. It would be fun if it's broken. That's nice. Oh, thank you. Yeah, thank you. It's early. Yeah, okay. I haven't, so, you know. So I haven't had breakfast either, so it's a time. Alright, so first the test. Can we get to the app? Yes, it's up. Baseline test. So this is basic fuzzing, right? Okay, we're going to feed it something. And the concept is if we feed it something that's like executable code and something random, those should be treated the same way. Alright, so let's say 6 characters. You can pick a format, alphanumeric, doesn't really matter for demo. And which parameter do we want to inject? Kind of key. Alright, so let's go through, it's going to run a bunch of tests. And basically what we're doing here is we're comparing, do a baseline to see what the size is when we feed it a good request. And then we're going to feed it injected requests and see how big the HTTP response is. So we actually see we had 2 successful injections. There's also a verbose mode that you can turn on in the option where it will actually show you the deltas. So we're seeing, did we get something a lot bigger? Did we get something a lot smaller back? If we did, then we probably had a successful injection. If we didn't, then it probably didn't work. So timing-based test will work for this demo for now. So you see we actually have 2. Remember we talked about the not equal? There's also another similar exploit where you actually use a greater than. So if I say, give me everything that's greater than nothing, right? So, which is everything, right? So let's just paste it in our web app. Alright. all the database records come back. But it gets better. So that was using a standard Mongo PHP driver query. We're going to use what's called a where query. Now, where query is something that Mongo actually says, don't use this. And it's kind of an interesting conundrum because they say, never use the where query, which is what you use to like massage your data and essentially is a parameterized type query. Never use where query. But then they also say, don't use stored procedures on the server. So if you need to manipulate your data before you write it to the database, how do you do it? Well, damned if you do, damned if you don't, right? So we're going to use this. Okay, one record found. So let's actually, we're going to keep the same here. File, options. We're going to change the app path. Same thing. Alright, menu, web app text. See, we're doing basically the same thing again. It doesn't matter. For this demo anyway, you can search parameter. Okay, so you see this time our associative array injections failed, but we had some other things work. Now, in the where query, because we're inserting into JavaScript that's being submitted to the server, there's a number of different things we can do. So I'm going to tell you how time-based tests work. Actually, now I'm going to show it right now because it may break something. But basically what I can do, there is no sleep function like we would do with a traditional blind SQL injection attack. But we can insert some JavaScript that is basically a while loop that checks the date over and over and over and over and over again until the date is 30 seconds in the future. Now, what's really interesting about this is there are many things that are single-threaded in MongoDB. And if you do this, the server will stop processing requests until your while loop expires. So, you know, let me check until the date's 100 years in the future. Yeah, so anyway, so I'll skip that. Now, you see we actually got a new prompt this time, because MongoDB Lesson 2.4 detected. What happens is, if we had a successful injection where we were able to touch the DB class, remember we talked about they took out access to DB class in 2.4, then we know we have less than 2.4 on the server, and we can touch other things in DB class, like database info, alright? Yeah, let's brute force the database info. So first thing we do, pull out a baseline, okay? So we're going to do a return true injection, like what we talked about. We're going to pull out a baseline size, and then we're going to start applying logic to return true. So we're going to say, if the first character in the database name is an A, return true. If it's a B, return true. If it's a C, and we're going to make HTTP requests until we get things that are the same size, and then it's the second character, so forth, so on, right? So if you got the database name in the back end as app user data, it's that same one we replicated earlier. Do we want to get the database user and password hashes? Yeah, let's do that. Found 2 users in the database. And it's going to sit here. And this is even easier because hashes are always the same length, so we don't have to inject a bunch of stuff to calculate the length of the database name. So, same thing's happening here in the background. We're just applying logic to our injection. Take a minute. Imagine as many characters we're having back here. So we got user hash, admin, map. And bear in mind we're doing this all through the web application, so same stuff we did with SQL map, right? But there's no SQL injection in SQL web application. There we go. Yep. Hash J, crack separate hashes, put in J. Let's crack the admin one. Let's do a dictionary attack because it takes time. That's with us. Alright. Found, username admin, password. All done through the web application. Hash. Press enter, continue, and you see there's our form of URL, so all that, and you see what we did return db.singleA.find, we injected that in, and we also used the 2.4 query, got a successful injection, so this.singleA is not equal to random things, it's this.singleA, so it exists in the MongoDB instance, so you can consult from Mongo perspective. Example. Turn off. How are we doing? 41 after. Okay, yeah, we got time. Okay. So this is a 2.4 instance. So we take out access to the DB class, right? So simple example. Clearly too early. Alright, set options, set the app path. And I'm really lazy. If you can't tell, I pretty much copied and pasted the same code for all three of these examples. So, okay, so you go back to the main menu, start web app text again. Checking to see if site's up, Same thing you did before. Like the email address, this doesn't matter. Go check the order search parameter. So you see what happened when we started trying to use the where query because we're trying to access DB class. The application actually returned an error. The MongoDB has some heuristic logic. One of the things that's really tricky, these applications will always return a 200 OK to everything. But the data it returns will just be the error message. So you can't do like error-based SQL injection where you're looking for HTTP 500 response or something like that. So, yeah, I'll start. Kind of show you. So we do, we see we're trying to actually measure HTTP response time. Go back to that application, and you see what happens. This actually runs out after a minute. I probably should have. Does anyone have any questions? Yeah. Yeah, I think 2.7 is the key. I've looked at release this a little bit. It's a lot of just functional fixes. It's not, there's no security enhancements. Mm-hmm. Right. Yeah, well, so the standard driver queries generally work pretty well unless you're on one of these platforms like PHP or Express.js, like we were talking about. The problem is, like I said, the stored procedures they say never to use. There are safe ways to write where queries where you actually you can pass the input as parameters. And I've got some examples of that I can show you, or I can send you later. So give you your email address. But yeah, there are ways to do it. It's just it's the same mistake people make for years. There are ways to write safe relational database queries, right? But people don't do it. So, but yeah, I got some examples I can send you of ways to do that safely, or I can put them up on the website. I'll have the project info here again at the end of the presentation. Yeah. Yeah, go ahead. Yep. Yeah. Right. Yeah. Yeah, that's a really good point. I did read about that. Yeah. Mhm. Mhm. Right. 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 Good point. Good point. I think it's fair, and like I said, they're really pushing the security model out to the apps, to the code. They, like I said, they're we'll let you shard, we'll let you store your data, we'll index it, we'll distribute it, we'll geo-replicate it, but you go into security, you're on your own. You do it in your code. Yeah, agreed. Yeah. So the key word you said there is should. Yeah, but I agree. I agree. Right. Yeah, sure. No, I mean, I don't have any problem people using Mongo. We use it where I work. But yeah, you have to do it right. I mean, mhm. Yeah, I agree. Agree. Let me finish up real quick. I'll take a couple more questions. So yeah, we this needs work. This actually going to false positive. This example does anyway. Because there's one response you get that's like way too small. But you see what happened. We measured the HTTP response time, varies for 30 seconds. So see this info. So URLs. So and you guys know what's coming. You paste it in. 2.4. We still get all the package. So anyway, I got two more slides. I'm going to go back to that one slide again. Yeah. Okay. So final thoughts, and some of this we were just talking about. That's a great discussion. We really appreciate the feedback there, by the way. NoSQL databases are a great tool, but you've got to understand what you get, decide if it's appropriate type of data that you put in it. Devs can and will make the same mistakes. They can make it for years if you give them the capability to. If you do things by default, if you allow them to use where queries, so forth, so on. Default settings are going to be left on. They always do. And the application layer security, the data right. So, questions? This is me, and this is the project homepage. The new code will be on GitHub here shortly. Email, Twitter, those things. And yeah, you had a question right here, sir. No, but that's coming into about 6. Yeah. Okay, so yeah, I'm sorry. The question was, if you put a node in the replication cluster, which this tool does not do dynamically right now, but it will in 0.6. Is it smart enough to, like, after you replicate some of the data, then to oh, I see what you're saying. You're talking about adding a node to a replication cluster. That's not what this is doing. This is actually just connecting and saying, copy the database here. So 0.6, you will actually be able to add a live node to a replication cluster and receive data in real time. So, okay, yeah. Hmm. Right, which means the application has to be written well. Oh, I'm being told to cut, but we can talk outside in the hall if you like. Thank you guys. Really appreciate y'all coming.